This is the second lecture on signals and systems, and we will be discussing transducers in this session. Now, in our last session, we were talking about the conversion of non-electrical quantities into electrical quantities. Actually, you also need the other kind of conversion in various systems. You also need to convert electric signals into non-electrical kind of signals. And the components which are capable of doing this are called as transducers. Now, what we are going to do is to look at a number of transducers and see their applications. The first transducer that we study is that of converting a position signal into an electric signal. And one simple way of doing this is to use a potentiometer. Let's say we apply the voltage V here. This is grounded and this is the sliding arm of the potentiometer. So let's say this resistance is R1 and this is R2. So if I take the output voltage at this point, it will be given by V upon R1 plus R2 multiplied by R2. Now R1 plus R2 is of course constant, so denominator is constant here. But as you change the position of the sliding arm, R2 will change and therefore the output voltage will change. This tells you how the position signal can be converted into an electric signal. Now we also need to convert the electric signal into a position signal. So how this can be done? What we need to do is to use an electric motor. So we provide the electric supply to this and the motor rotates. So if you want to achieve a particular position by rotation of the motor, of course you will require some kind of control system which will ensure that the motor will stop at the desired point. Now in order to see one application of this, let us think of the positioning of, let us say, a satellite antenna which may be quite bulky and it will not be very easy to rotate it by hand. So you'll require some kind of an external system, some kind of motor control system which will rotate the antenna. So we have got this motor control. Now you will have a control chamber which is at some distance away, and you will have someone here who is trying to set the antenna to the desired position. So he provides the position signal from here. It is transmitted electrically to the motor control unit and the antenna is rotated to the desired position. So this is how you can see an application of the position transducer. Next, let us look at another kind of transducer. Let us say a temperature transducer. So here we want to convert a temperature signal into an electric signal. And there are various ways of doing it. One way of doing it is to use what is called as a thermocouple. Thermocouple is essentially a junction of two dissimilar metals, and when there is a difference of temperature, it will generate a voltage which will depend on the temperature. So that is your thermocouple. But then how about converting the electric signal into the temperature signal? Well, all you require is a heating coil which is resistive. So when the power is dissipated in this, the temperature will rise. And as an example of these two different kind of transducers, one temperature to electric and the other electrical to temperature. Think of one industrial application where, let us say, you have some chamber and the temperature in the chamber is required to be maintained at some specified position, specified value. So we have got a temperature transducer here. We take the output and then we have a comparator. This comparator will compare the output of the transducer with some reference value. So this will indicate the desired temperature. Now, when the temperature does not have its actual value, we need to provide more current through the heating element. So we have a power control unit here, a power control unit, and this power control unit will drive the heating coil. So if the temperature rises above the reference value, this information will be provided to the power control unit and it will reduce the current through the heating coil, bringing the temperature to the original value. On the other hand, if the temperature drops, then again the comparator will generate an output signal and the power control unit will increase the current through the heating coil so that the temperature will rise to its original position. So this gives you an example of the use of temperature transducers. Let us now look at the third kind of transducer, which we have already discussed really. Let us say sound to electrical, and we all know that we can use a mic to convert sound signal into an electric signal, and to convert an electric signal to sound signal, what we require really is a speaker. So you provide the electrical signal to the input and you get the sound signal at the output. We have already seen an example of this. Let me quickly repeat it. In a public address system, someone is speaking here. So the mic will convert it into electrical signal, which can be amplified by means of an amplifier, which is then transmitted to a remote point, and at the remote point it will be reproduced. So this is how the sound transducer can be used. Then the fourth kind of transducer that we would like to study is the light transducer. So how to convert the light signal into an electric signal. Again, there are various ways of doing it. One way is to use a phototransistor. So when the light falls on it, the characteristic of the phototransistor changes and you get your electric signal. What about the conversion from electric signal to light signal? This is simplicity itself. If you have some electric signal, you can connect it to, let's say, some kind of a bulb, and depending on the intensity of the electric signal, the intensity of the light will be produced accordingly. So these are the light transducers. Now let us see one industrial example of this. Let me clear the slide again. Suppose in an industry, let's say you have a conveyor belt and objects are passing over it, and let's say you want to keep a count of these objects. So what you can do is you can use a light source on one end. At the other end, you can use a light sensitive device. So when the light is interrupted because of the presence of the object, it will be sensed, and this information can be sent to a counter, which will enable you to count the number of objects. Another well-known example of the light transducer is, of course, the video camera, which converts a picture signal into an electric signal. A picture signal, which is essentially consisting of large number of pixels emitting light. So picture signal converted into electric. And when it is transmitted at the other end, you will require either a TV or a monitor in order to convert the electric signal back to picture signals. So these are some of the examples of the use of transducers. Although we have seen a number of engineering examples, it will be interesting to see that a human body also uses number of signals and transducers. For example, if you consider the ears act like microphones. They will convert the sound signal into an electric signal and send it to the brain, which will interpret the sound. Similarly, if you think of eyes, you will find that when the light falls on this will work like a video camera and again send the signal to the brain, which will interpret the pictures. And of course, needless to add that the mouth that you have got works like a speaker. And all these transducers and signals work together in order that a human being is capable of carrying out the activities that he needs to. For example, uh, suppose you have a bull here which is charging at you. Let's say some bull which is coming charging. Here's an eye. So when a person sees that, the eye will send a signal to the brain, and brain will send a signal to the limbs so that you are ready to run. So I think that gives you an introduction to various transducers and their applications, and that's all for this session.